All right, now we have question 3. Question 3, we have 3.1. It says, given the series 1 plus 2 plus 3 up to 5,000, write down the series in sigma notation if all the powers of 4 are removed from the series. Okay, so we have this series 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 5,000. So we're given this series and we're told that we should write this in sigma notation. But now the way we should write this one is when all the powers of 4 are removed. So what do we mean by the powers of 4? By the powers of 4 we mean 4 to the power anything, from 4 to the power negative infinity to 4 to the power positive infinity. But here we will start with 4 to the power 0 because 4 to the power 0 lies in the series. So we will have 4 to the power 0 plus 4 to the power 1, which is equal to 4, and we have 4 to the power 2. We also have 4 to the power 3. We also have 4 to the power 4 plus 4 to the power 5 and plus 4 to the power 6. Alright, so 4 to the power 0 is 1 plus 4 to the power 1, that is 4, plus 4 to the power 2, that is 16, plus 4 to the power 3, that is 64, plus 4 to the power 4, that is 256, plus 4 to the power 5, that is equal to 824, plus 4 to the power 6, and that is a 49.6. Alright, so these are the powers of 4, and this is our original series, whereby we will have to take out or remove the powers of 4. So now we have this information. How do we write this in sigma notation? Okay, here is what we can do. First, we can write this whereby it includes the powers of 4 in sigma notation. We write that in sigma notation, and then we subtract these powers of 4. Okay, to do that, let us first find the equation of this series, or the general term of this series. So to find the general term of this series, we first have to determine what kind of a series this is. Is it arithmetic, is it geometric, or is it something else? So first let us check if it's arithmetic. We will have term 1 minus term 2. Term 2 minus term 1, that is 2 minus 1. So that is 1, and that is term 3 minus term 2, that is also 1. Term number 4 minus term number 3, that is still 1. So we get a common difference throughout. So that means this is an arithmetic sequence. This is an arithmetic series, not a sequence. It's an arithmetic series. So to get the general term of this arithmetic series, we have this formula, which is Tn is equal to A plus n minus 1 multiplied by D. So this is Tn equal to A, in this case, is the first term, so that first term is 1 plus n minus 1 multiplied by D. So the common difference here is a positive 1, so we will multiply with a 1. So Tn is equal to 1 plus n minus 1 multiplied by 1. 1 multiplied by n, that is a positive n. And then 1 multiplied by negative 1, that is a negative 1. So Tn, or the nth term, is equal to 1 minus 1, that's a 0. Therefore, the nth term of this series is n. So if we were to write this in sigma notation, whereby the powers of 4 are included, it will be the sum of n, which is this n, and this is for 5,000 terms, starting from n is equal to 1. And then we come to the powers of 4. With the powers of 4, let us first determine the general term of this series. To determine the general term of this series, we first have to find what kind of a series it is. Is it geometric or is it also arithmetic like this one? So 4 minus 1, that is a 3. 16 minus 4, that is a 12. So it's not arithmetic. Let us check if it's geometric. 4 divided by 1, that is 4. It's 4. 16 divided by 4, that is still 4. 64 divided by 16, that is still 4. So this means this is a geometric series. So let us find the general term of this series, or the equation which determines this series. So we'll do that by using the formula. The nth term is equal to a r to the power n minus 1, where a is the first term and r is the common ratio. And here a is equal to 1 and the common ratio is equal to 4. So the nth term is equal to a, which is a positive 1, multiplied by r, which is a 4. And that is to the power n minus 1. So that means the nth term is equal to 4 to the power n minus 1. So this is the general term of the powers of 4, from 4 to the power 0 up to 4 to the power 6. So to write this in sigma notation, that is the sum of 4 to the power n minus 1 of 7 terms, because it's 1, 2, 3, 4, 5, 6, 7 terms, whereby we start from n is equal to 0. So for the powers of 4, this is how we write them in sigma notation. The question said we should write down the series in sigma notation if all the powers of 4 are removed from the series. So this is what we will remove from this. So to write this in sigma notation, it will be this minus the sum of 4 to the power n minus 1 of 7 terms, starting from n is equal to 0. So this is our final answer, and that is just how we do it, ladies and gentlemen. Up next is 3.2.